Today we're talking about chain rule and derivatives of trig functions. So by the end of the period, you will have all of the different rules to find the derivative of any type of function, whether it is a polynomial function, a trig function, exponential, quadratic, rational, etc., etc. Okay? So, and the thing is with chain rule is that you're basically taking through the derivative of composite functions. You guys remember what composite functions are, correct? Blank stares. Come on now. Composite functions. Composition of functions, maybe. Come on. Y'all, huh? A function within a function. That is what a composite function is, okay? Think about it. The symbol, you remember what the symbol is for composite?
Circle.
The open circle,
Okay.
right? Where you would do what? You would put a function inside a function.
Yeah.
Yes, there you go. Okay? That is a composite, okay? Composition of functions. Really?
Yeah.
I know.
We just said
Alright, so yes, it's when you apply one function to another, okay? A function within a function. So all of these are examples of composite functions, okay? And the thing is, the thing is with when you're doing derivatives of these types of functions, you are going to apply what's known as the chain rule. Now the thing is, you have to be able to identify basically what are the two functions that make up basically the composite. Okay, so basically what is that inside function? What's the outside function? That is very, very important when it comes down to chain rule. Okay? So what I want to do is I want to take some of these examples and just make sure that we can do this before we jump into finding the derivative of them. Okay? So each one of these, there are two functions. Now we are starting with the more simple of the chain rule types of problems. So to realize that there are going to be some problems where you have to do like chain rule multiple times. So do be aware of that. We'll start with the easy ones for right now. Okay? So there's one outside function, there's one inside function. So if I look at the very first example of 2x minus 3, that quantity squared, what would you say is the outside function?
X squared.
It would be x squared. And then what would be the inside function?
2x minus 3.
2x minus 3. Okay, because if I were to do the composite of it, I would put 2x minus 3 in for x, and then I would square it to get what you see over there in the green. Okay? Let me hear from two different people, okay? What about the next one? What is the outside function? What will be the inside function? I hear from two different people.
It's my left hand.
Square root of x.
It will be the square root of x. Okay? So then what am I plugging in for x to get what's in the green? Let me hear from somebody different. Say 3x what?
3x squared.
Very good. Because I'm taking that whole function, I'm plugging it in for x to get what I see in the green. Okay? Let's look at the next one. What is my outside function? Or better yet, maybe you can see the inside function first. You know, give me one of the two. Okay, let me hear from two different people. Sarah?
Inside would be 3x.
The inside will be 3x to the fifth, and I'm plugging that in for Grady.
Natural log of x.
The natural log of x. Very good. Okay? Let me hear from two other people for the next one. What is my two different people? Yes?
The inside function is 4x to the 3rd.
Very good. It's 4x to the third.
Plug this in for x.
So for the last one of 5, the quantity x to the third plus 3x to the fourth.
The outside function would be 5x to the 4th.
Very good. The outside function would be 5x to the fourth, which means that my inside function would be
X cubed plus 3x.
okay. So being able to identify what those inside and outside functions are can be very helpful when you are applying the chain rule. Okay? Chain rule. Ooh, I so love this one. That's what it's saying. Says that if f of x equals u of v of x, so there's basically the composite function to help f of g of x, just use the v. Then the derivative is basically the derivative of the outside function with respect to the inside function multiplied by the derivative of the inside function with respect to x, or whatever variable they're using. Okay? So we're just gonna, after you guys get this down, just gonna jump in and see how the derivative is done. We'll do a few together, and then you'll try some on your own. Oh, wait,
Does that mean you have to fix the second part too?
Alright, so can you identify what the two functions are? What's the inside function, what's the outside function? U represents the outside function, V represents the inside function. Hey, I haven't heard from a few people, so from the folks I haven't heard from, one of y'all give me the outside function.
4x
Is the what?
is
Which one? Is it U or V?
u.
It is U. So that means the inside function would be 5x cubed plus 2, yes. So it's good to be able to recognize that, because when you are finding the derivative of it, you are going to be using chain rule, because you're not going to sit there and try to expand that and then distribute a 4 and then try to get it. That's too much. You're timed. You are timed. So to find the derivative, you take the derivative of the outside function with respect to the inside function. In other words, you take the derivative of u, but instead of writing an x, you're going to write the v function. So what's the derivative of 4x to the 6? What is that? What's the derivative of that? 24x to the 5th. But instead of writing x, we're going to write the inside function. That's what it means by taking the derivative of the outside function with respect to the inside function. So instead of it being x, it's the inside function. Then you multiply it by the derivative of the inside function. What's the derivative of 5x cubed plus 2?
15x squared.
15x squared.
Are you sure?
Are you sure? How do you know? Explain to us.
That's there.
No, from here, we've done the hard part. Now all we really have to do is just multiply, like simplify this down just a little bit, okay? So any numbers that are on the outside of this function, which are these two things, we just multiply them together, and then that will be your final answer. So what's 24 times 15?
720. No, that's not 720. That's 360.
Wait, I have a question actually. The 15x squared is within the function, so why are we?
It is 360.
It's, you multiply this entire piece right here by a 15x squared.
360.
Oh,
So that
the
means
only
you're
other
on-
line is 24.
360.
It's 360?
360. It was
Okay.
360.
So it's going to be 360 x squared times 5x cubed plus 2 to the 5th power. That would be our derivative.
That one part's still
So we
not
kinda,
bad.
like,
Okay, so
solve
you
that out
multiply
to see what we
24
get.
times 15 to get 360, correct?
All right, 24 times 15 and 360, yes.
But why did you multiply it by 15 with x squared if that was? Well, because
See-
it's all multiplying and it's just
There's no-
easier to multiply 24 by 15 and 24 by 5 times 2.
Right, because technically what you would end up doing is basically you would distribute this 24 to whatever that is expanded, and then multiply every single thing. So you can
Exactly.
So really, truly, you could expand this and then multiply everything by 360x squared, which you would want to do. But that's how big your numbers would be if you actually try to sit there, expand it, distribute, and then take the derivatives. You done wasted almost 10, 15 minutes, and heaven forbid you make a mathematical error somewhere. Yes, sir.
Oh. Well, we kind of got close.
Here are the next two. We're gonna look at these two next. Huh? Very good. So my outside function is the square root of x, and we start over. If anybody wants my inside function, raise your hand.
4x squared plus 1.
4x squared plus 1. So when we take the derivative, we're going to take the derivative of the outside function with respect to the inside. Then we're going to multiply that by the derivative of the inside. What's an easier way to write this?
X is 1/2.
X is 1/2. So when we take the derivative of the outside function, raise hand. What is the derivative of the outside function, Matthew? What's the derivative of this function? Yeah. But instead of writing an x, what am I going to write?
4x squared plus 1.
And then you multiply that by the derivative of the inside. What's the derivative of 4x squared plus 1, Sarah? There you go. So then to simplify that, what things am I going to multiply to simplify this? Manny? 1/2 and 8x. So what's half of 8x? 4x. And I can't leave my exponent negative. How do I make it positive? Put it in the bottom and square root. And that's your derivative.
So even like the baby functions.
Alright? So, I need my inside and my outside functions. So raise hand, somebody give me one of the two. Rob.
Outside functions, yes.
Very good. And my inside function is Sarah? X squared. Now x is a tad bit different because, you know, unlike like A and B, you have parentheses, you had a square root. You had it so it looked like, hey, it's inside of the square root. Well, this x squared is inside of the exponent of e to the x. So think of it like that. Okay? So now to take the derivative. Derivative of the outside function is e to the x. But we're not going to put an x,
We're gonna put x squared.
put an x squared. Mhm.
But then it's.
But then you have to multiply it by the derivative of the inside, which is 2x.
Why did we use ex? Is ex the derivative of ex of ex?
That's we talked about that
Why
on
squared?
Hmm?
Why we squared?
because remember it's with respect to the inside function, which is x squared. So whatever that was, that's whatever the inside function is, we put that there instead of x. So then our final answer is just 2x e to the x squared.
I don't like that as a square.
And here's an example with the chain rule inside of the chain rule. Okay? So you can look at it like this. You can look at it like this. You have, of course, e to the x. And then you have your child function. Okay? So when you take the derivative of your outside function, you get e to the x. But instead of writing x, we are going to write the entire inside function. Then we multiply that by the derivative of the inside. The inside is yet another chain rule, where you have your outside function as 2x to the 4th, your inside function as 3x minus 1. So then when you take the derivative of this, you basically are doing chain rule yet again. What's the derivative of 2x to the 4th?
8x cubed.
But instead of writing an x, we're going to write the inside function. And then you multiply that by the derivative of the inside, which is 3.
I'm doing
So
everything.
then when you multiply them, you get 24, 3x minus 1 to the 3rd, e to the 2, 3x minus 1.
I was right until you
Now I
got
got
to
an
that
answer.
eight.
Okay, I got that answer, but
This is an example of chain rule within a chain rule, okay? So once you get to that derivative part of that red function, you yet again have to do the chain rule and then multiply everything together. Okay? So this is a double chain one. Okay? So I had to take a trip for Friday, but that's fine. So all right, any questions about this one?
I got a question.
Yes?
So, once you found,
All right, let's look at this one. I want to do this one with you guys. Please, can I?
yes, yes.
All right.
Faster.
Here we go. So, here's an example of,
Quotient rule inside chain.
No, this is 2 chains in the quotient rule.
yeah, 2 chains of quotient.
Oh my God.
Here we go.
This
So-
is quotient rule in real life.
We have
I was listening to this.
Alright, here we go. So, we got our two functions. We have our outside function, which is what? ln(x). Then you have your inside function, which is clearly.
X over X squared plus one.
So when we take the derivative, using chain rule, we take the derivative of the outside. What's the derivative of ln of x? 1 over x. But I'm not going to write it x.
You're gonna write
X over
Okay? And then you multiply that by the derivative of the inside. Now to do the derivative of the inside, you have to use quotient. So quotient is what? Okay, so let's do it in pieces. Low, d high. What's the derivative of x? 1. Minus
Low.
high,
D.
d low. What's the derivative of
2x.
all over
low.
low low? Let's simplify this before we put it beside the red part. So we'll get x squared plus 1 minus
2x squared.
2x squared all over low low. And Matthew, what does that give me? 1 minus x squared. This is what is multiplied. Okay.
I have a question.
Yes.
When we plugged in our inside function
Uh-huh.
below,
Yep.
why didn't we take the double chain first?
Well, this one actually ended up not to be a double chain. It only ended up being the chain with the quotient. Because when we took the derivative of the inside function, that's what you see in the orange.
Okay.
And there were no chains within that.
Isn't it 1 minus X squared? Yeah, just square.
Alright, now this red fraction. I can't have a fraction within a fraction, so what do I need to do? Keep change flip. So basically this whole thing is going to end up being flipped. And I'm going to multiply that. Say what? Sure does. Say everybody see which one cancels out? What cancels out?
The left numerator with the bottom left, right.
Woo! Alright, here we go. Final answer. And doing that will allow you to optimize your profit, your maximum profit, or maximum area, or et cetera, et cetera. But we will get to applications in due time. I need to make sure you guys can do this first. Yes,
Did we distribute that X on the bottom?
you can. You definitely can.
On a